Ever wonder how those crazy smart AI assistants like, ChatGPT actually work?
Yeah, it's pretty wild.
Well, they're powered by things called large language models, LLMs for short.
Right, LLMs.
And here's the thing, these LLMs are getting so massive, they need a crazy amount of computer power and storage.
Yeah, they're huge.
Like trying to, I don't know, cram a supercomputer in your pocket.
Haha. Yeah, good luck with that.
Not exactly practical, is it?
Not really, no. But that's where this thing called distillation comes in. It's like shrinking that massive supercomputer brain down to something that can run on your phone.
Oh, wow, without losing all its smarts.
Exactly. It's pretty cool.
So it's like creating a more, I don't know, compact and efficient version of the original.
That's a good way to put it, yeah.
I got to hear more about this.
Well, you can think of it like a teacher and a student.
Okay.
So you've got this big, super smart teacher model. It's already been trained on mountains of data. And then you have a smaller student model. And it learns, it learns to copy what the teacher does.
Interesting.
Yeah.
So this transferring knowledge thing is fascinating. What makes that different from just like straight up copying the data?
Well, it's not about just copying. It's more like it's capturing what the teacher knows, like the essence of it.
Yeah.
The student model. It learns the patterns, the connections that make the teacher so good.
So it's like learning the why behind the answers, not just memorizing.
Exactly.
Exactly. That's really neat.
Yeah.
It's like the students learning from the teacher's experience, not just their notes.
Right. Exactly.
So who came up with this idea? Like, who are the masterminds behind this?
Well, the idea of using distillation for neural networks, it was these guys, Jeffrey Hinton, Oriol Vinyals, and Jeff Dean.
Wow, a real AI dream team. But before we get too deep into the how-to, I'm kind of curious, why is the size of these LLMs such a big deal?
Well, take, for example, Meta's Llama 3.1. It's a powerful LLM, but it has, get this, 405 billion parameters.
Whoa, that's a lot.
Yeah, a lot. To give you an idea, that needs 2 terabytes of storage.
2 terabytes? That's like, what, a whole library of movies?
Pretty much, yeah. And to run it, you need almost 1 terabyte of this special memory GPU RAM.
Okay, so that's huge. I can only imagine how expensive it is to even, touch that kind of computing power.
Yeah, the cost is a big problem, and accessibility, too.
Right.
These massive models, they're just not practical for everyday use.
So it sounds like distillation could really change the game here,
Yeah.
Make these incredible models more, I don't know, manageable.
Absolutely. The goal is to make smaller, more efficient versions that can run on more devices, but without losing too much performance.
Okay, so how do we actually, shrink these giant AI brains? I'm ready to get into the nitty-gritty.
All right, well, let's break it down. So first, you start with your big, fine-tuned teacher model. And then you create a smaller student model. This one is designed to, learn from the teacher.
Gotcha. So we're not actually shrinking the original. We're training a whole new, smaller model.
Exactly. Imagine training a rookie based on what a veteran knows.
Okay, that makes sense. So then what?
So then you freeze the weights of the teacher model. It's like saying, all right, you've learned enough time to teach.
I like that.
And then you have both the teacher and the student models make predictions based on some data. And then you compare them.
Right, how well is a student doing?
Exactly. You calculate the difference between what the teacher predicted and what the student predicted.
Okay.
This difference is called the distillation loss.
So the smaller the loss, the better the student's mimicking the teacher.
You got it. But there's a little twist. See, the teacher model is already really good, so its predictions are really close to the actual correct answers.
So if the teacher is always giving the perfect answer, wouldn't that kind of limit the student's learning?
You're sharp. That's a good point. And that's where this idea of temperature comes in.
Temperature. Were we talking about, how hot the computer gets?
No, not quite. In this case, temperature is this parameter that controls how creative the teacher is.
Wait, AI can be creative?
Oh, yeah, for sure. By increasing the temperature, we can make the teacher's output less, rigid.
So instead of just giving the most obvious answer, the teacher gives a wider range of possibilities.
Exactly. And that helps the student learn more.
It's like encouraging the teacher to think outside the box and then share those ideas with the student.
Precisely. Helps the student get a deeper understanding.
That's pretty cool. It's like, those times you're using a chatbot and it just keeps giving you the same answer over and over?
Yeah.
That sounds like this temperature thing could fix that.
You got it. Makes the interaction way more dynamic and, interesting.
So how does the student actually learn from both the teacher's softened answers, and the actual hard facts?
Good question. So what we do is we combine the distillation loss, which you remember is the difference between the teacher and student, with something called the student loss.
Oh, okay.
That's the difference between the student's prediction and the actual correct answer.
Gotcha. So it's like a two-pronged approach to guide the student.
Yeah, exactly. And we use this combined loss to fine-tune the student model using something called backpropagation.
Backpropagation. I've heard that before,
Yeah.
but not sure what it means.
Think of it like this. The student takes a test, right? And based on how they do, they go back and change how they study to do better next time.
Oh, that's a great way to put it.
Yeah.
So this distillation process, it sounds pretty intricate.
It is, but it's really effective.
I'm excited to learn more about, like, the benefits and the limitations of this whole approach. But first, I think we need a quick recap of what we've covered so far.
Yeah, sounds like a good plan.
Okay, so we've got the basics of distillation down, how it all works.
Right.
Now let's get to the fun part, the advantages, the good stuff.
Yeah, the good stuff.
I'm sure folks listening are wondering, like, how does this help me? How does this benefit me?
Yeah, that's the important part.
So let's talk about that.
Well, one of the biggest wins with distillation is cost.
Oh,
It can really cut down on costs because the student model is smaller. It doesn't need as much processing power, as much memory.
right. Smaller model, less energy to run it.
Exactly, yeah. So that means lower costs for everyone, for the people who make these models and the people who use them, whether they're using them in the cloud or on their own device.
So it's not just making AI more accessible, it's also making it, like, more affordable.
Exactly, yeah, that's a big part of it. And it's not just cost. Distillation also means smaller model sizes, which means they can fit on devices with less storage.
Oh, okay.
Think about, smartphones, wearables, even those tiny sensors in smart homes.
So we could have, like, powerful AI on everyday devices.
Exactly.
That's wild. Like having real-time translation on your phone.
Yeah,
Or, I don't know, personalized health monitoring on your watch.
absolutely.
That's really making AI accessible to everyone.
Yeah, that's the goal. And because these distilled models are smaller, they can also process information faster, give you answers quicker.
Oh, okay. So no more waiting forever for a chatbot to answer a simple question.
Right. Or for that summarization tool to chug through a long article.
Uh-huh. Yeah, I've been there.
Distillation makes everything snappier, more responsive, makes the whole AI experience way better.
Okay, this all sounds amazing.
Yeah.
But I got to ask, are there any, like, downsides? There's got to be some trade-offs, right?
Yeah, that's a good point. While distillation has a lot of advantages, there are some things to keep in mind. For one, it doesn't work equally well with every type of model.
Oh, okay. So it's not a, like, one-size-fits-all solution.
Right. It tends to work better with certain types of models, like encoder-only models, which are used a lot for things like text classification, understanding what a text is about.
Makes sense. And even with models where distillation works well,
Yeah.
are there any, I don't know, performance hits we need to be aware of?
Well, the student model learns a lot from the teacher, but there is a chance of some accuracy loss,
Oh,
especially with very complex models. It's kind of like compressing a big file. You might lose a tiny bit of detail.
So it's about finding a balance between, like, efficiency and accuracy.
Exactly. And how well distillation works also depends a lot on the quality of the training data and the specific techniques used during the process.
Sounds like there's a lot of expertise involved in getting this right.
Oh, yeah, for sure. It's a powerful tool, but you got to use it carefully to get the best results.
Okay, so we've looked at the good and the maybe not so good.
Right.
But now I really want to see how this all works in real life. How is distillation actually making AI more useful, more impactful?
That's where things get really interesting.
Right. So we've talked about how distillation works and all the cool stuff it can do.
Right, right.
But now I want to know, like, what does this mean for, everyone listening?
Yeah, how does this impact the future of AI?
Exactly. Yeah.
Well, distillation is really breaking down barriers, It's making things possible that we couldn't even dream of before.
Oh, okay.
It's taking powerful AI out of those expensive data centers and specialized hardware.
So it's not just for big companies and research labs anymore.
Exactly. Imagine, like, your smartphone could actually diagnose a skin condition using a really sophisticated AI model
Wow.
or translate a conversation in real time, like right there in your hand.
That would be incredible.
Yeah.
It's like having a team of experts in your pocket.
Yeah, that's a good way to put it. And it's not just smartphones either. Think about all those other devices, those edge devices,
Oh, right, yeah.
like smart appliances,
Yeah.
self-driving cars, all that stuff.
So they can run these powerful AI models locally.
Exactly.
That's wild. So we're bringing AI to like the front lines where the action is happening.
Exactly. And for businesses, think about customer service.
Yeah.
Distilled LLMs could totally revolutionize that.
Oh, yeah.
Imagine chatbots that are actually super fast and can handle really complicated questions.
No more waiting on hold for hours.
Yeah, exactly. Personalized support, 204/7. It'd be a game changer for everyone.
It would. It would. So distillation, it's making an impact in a lot of different areas, huh?
Yeah, all sorts of industries. Healthcare, finance, manufacturing.
So it's making things like medical diagnoses faster.
Exactly. And real-time fraud detection, better production processes, the list goes on.
Wow. So distillation is really making AI more practical, more impactful, in all these different applications. But I'm kind of curious, are there any other techniques that people are using along with distillation to make these models even better?
Yeah, good question. Distillation is a big part of it, but it's not the only thing. There are other optimization techniques like pruning and quantization.
Pruning? Okay.
Yeah, it's kind of like imagine you have a tree and you're trimming away the branches that you don't need.
Makes sense.
You're making the model leaner without, losing what makes it work.
Okay, I got it. And quantization, what's that about?
That's a good one. It's like imagine you're using a smaller unit of measurement.
Oh, okay.
So you can represent the same information, but with less data.
That's a really good way to explain it.
Yeah, so it's all about finding these clever ways to make the model smaller without hurting its performance.
So AI development is like constantly changing and improving.
Oh, yeah, absolutely. There's always something new coming out, new ways to make these models more powerful and accessible.
It's a pretty exciting time to be following this stuff, huh?
Yeah, for sure. It feels like the possibilities are endless.
So what does all this mean for, everyone out there listening? What's the big takeaway from our deep dive into distillation?
Well, the main thing is the power of AI is becoming more and more available. It's getting more affordable, easier to use, easier to integrate into your life.
It's like the doors to AI are wide open. Anyone can walk in and see what it's all about. It's amazing to think, like, what could you create? What could you explore if you had super intelligent AI right there in your pocket?
That's a great question. The future of AI is happening right now, and distillation is playing a huge role in making it all possible.
And that's our deep dive into the world of AI distillation.
Yeah, thanks for listening, everyone.
We hope you enjoyed it, learned something new, and maybe even feel inspired to go out there and explore the amazing world of AI. We'll see you next time.